All right, looks like we're live. Hello and welcome to Mr. Linford's live stream. Today we are going to be reviewing some of the sections from last week. Towards the end of last week, I wanted to review in particular the exit ticket problems from section A1 and then a problem from the previous section 6.6 to 6.5. And then I'd like to get into one of the two sections that you have to work on today. Today you have to work on section 8.2 and 8.4. I'd like to work through section 8.2, a little bit of that, and then during our second live stream, really focus on section 8.4 today. Again, all of these live streams are recorded and posted on the YouTube video page, so if you need to go back and watch any of them, you're always welcome to. And if you have any questions, please have a live chat going on the side here, so message me if there's any problem in particular you'd like me to review or anything you want me to go over, or if you have any questions about the problems I'm currently working on, you can let me know as well. And for our second live stream during the day, that's going to start at 12:30. Feel free to email me ahead of time any questions that you'd like me to review in that particular live stream, or any things you'd like me to go over more in depth. Now let's start with this section A1. This was if you're following along in the book, this is the appendix section, and this is where they have just general more factoring practice. This is a fun, well, what I consider fun, factoring practice where you have 4 terms and they're of different variables. So you'll notice you have 2 x variables, you have 1 y variable, and you have 1 constant term. So the curiosity is, how do you go about factoring this? Well, generally speaking, what you would do for a 4-term polynomial is grouping. And grouping would be where you try to put parentheses down around the first 2 terms and the last 2 terms, and you try to factor out the GCF of each, or you just try to factor each one down as best you can. So the first one, I could factor out the GCF of x, and I'm left with x minus 6. Here, I could break this down to 3 minus y times 3 plus y by the difference of squareds. But oh wait, this answer right here, that's nothing. That doesn't help me factor down any further, right? Because I want to write my answer as the product of factors, and this is still the sum of these things. So there's nowhere I can go with this. Well, what's interesting is really the idea of grouping. That technique that we learned for 4-term polynomials to group them, where you group the first 2 and the last 2, that's just one form of grouping. Really, what grouping says is, yeah, okay, there's no GCF in the entire thing, right? And maybe when you put the first 2 parentheses down and the second 2 parentheses, maybe if you do the first 2 terms and the last 2 terms, it works. Maybe it doesn't work. The idea with grouping is try to place parentheses somewhere, in a very, what I might say, an educated decision. Make an educated decision about where you place the parentheses in the polynomial. Now, it's suggested that we are first going to try to group the x's together. Obviously, we shouldn't group x's and y's together in parentheses because they're different variables, right? We don't want to try to factor something with different variables. So I do want to put parentheses down, but when I tried it with the first 2 terms, it didn't work. What if I try it with the first 3 terms here? What if I try it with the 2 x's, the x squared and the negative 6x, and what if I include the number 9, the constant, right? Because I don't want to include the other variable, because that would throw things off. So let's try to group now where I've put parentheses around the first 3 terms, and you can imagine a parenthesis around the last one, but that doesn't matter. Factor down what's in the parentheses. That's the idea of grouping. You try to factor down what's in the parentheses to get your answer in some form that you can keep working with. So if we factor x squared minus 6x plus 9, we're going to get 2 binomials. Obviously, the first term in each one's going to be an x. Now let's think. We need things that multiply to give us positive 9, but add to give us negative 6. Well, that should be negative 3 and negative 3, because those will add to negative 6, but they'll multiply to give positive 9 minus y squared. So really what we have here is x minus squared minus y squared. I have an expression squared subtracted from a term squared. So really what I have here is I have something squared minus something squared. That's the difference of squareds. If you remember the difference of squareds, I'll write the formula up here in red. A squared minus B squared equaled A minus B times A plus B. We're going to use that formula right here. Here, the A, I should write it to the side here. We're going to say A is x minus 3, and B is y. We're asking ourselves, what are the things that are being squared? Well, x minus 3 is being squared, and so is y. So if I use that formula, I would get x minus 3 minus y, and x minus 3 plus y. I have what A is in the first spot, so that's A, and that's A. And right here is B and B. So you'll notice I'm subtracting it and I'm adding it on. So really, this whole idea with grouping, by putting these terms together, and again, grouping, there's no set rule that it must be the first two and the last two terms, or the first three terms and there's no set rule for it. The idea is you just try to be kind of clever with how you pick this. Try to put parentheses somewhere in the polynomial, so that way you can factor down part of the polynomial to get it in a form where you can factor the rest down. So we tried our standard technique of the first two term and the last two terms. Didn't work. The other technique is, well, if I'm trying to make an educated decision here, I'm going to try to group the like variables together, but then I'm also going to try to include the extra number with that, something I didn't do last time. Let's see if that works down here for the second problem. Here, I could try to group the first two and the last two terms, but immediately I'm thinking this isn't going to work because look, this has multivariables in it. I could basically use the difference of squareds to break this down, and I get x plus 2y and x minus 2y. But nothing over here is going to have anything to do with an x, so it's not really going to work. Let's take a look here. I could move out a negative 5. I'm going to factor out a negative 5, and I'm left with 4y plus 5. So I just factored out the GCF of this second group here. Take a look at what I have here. Can this be factored at all? No, there's no way. This is not in any form that can be further broken down. There's no GCF in it. There's no special form like the difference of squareds. There's nothing to this. So let's try to get rid of all of this. And let's try to make a more educated decision about where we place our parentheses. So, okay, our standard method didn't work. Well, we could try to group. Let's see. What if we rewrote it as x squared? And what if I had the minus 4y squared, the minus 20y? I want those together, obviously, because of the same variable, and I don't want to group things with the x and the y. But when I did the two-term thing, that really didn't work. Like, there's nothing in common. They didn't have anything in common, any GCF to factor out. So what if I try to not just have the variables of y's together, but also let me throw in that number as well, okay? Because I tried it already with the two terms, didn't work. So let me try to take both the y's, and I'll include the negative 25, okay? First up, I don't like dealing with negative leading terms, right? That's an irritation to me. So what I'm going to do, and generally speaking, we say don't work with the negative leading terms. So I'm going to factor out the negative, and we're left with 4y squared plus 20y plus 25. Now, notice that when I rewrote this, I didn't put parentheses here. I didn't do that. Why? Because of this negative on the outside. That would mean I would have to distribute everything through. No. You got to include the negative with it. So I turned it to a positive, and I put the negative on the inside. Okay? That's the idea here. Okay? This negative is attached to the 4. It doesn't mean make the whole thing negative. It just means the 4 is negative. So be careful where you put parentheses, okay? So when I factor it out, this turns into this. And how can you check? Just redistribute. When you redistribute, you'll get it back. Okay. Now, the idea with grouping is, let's see if our educated decision was a good decision or not. We are going to try to factor down what's in parentheses. Now, you can go ahead and do the AC method with this, but we know we could also just factor out a 4, and we're left with a y squared plus 5y. No, wait, we can't do that. Never mind. I'm getting ahead of myself. I was thinking there was a GCF in there. But, oh, well, you can go ahead and do the AC method if you want, but there's actually, this is what's also called a perfect square trinomial, where the first term is squared and the last term is squared, and the middle term is the product of the 2 terms, so or double the product of the 2 terms. So here, I'll show you real quick. The answer you should get when you do the AC method to this is 2y plus 5 times 2y plus 5. Okay, go ahead and do AC. You'll figure that out. Now, when we get this is the same thing as saying, well, this is really 2y plus 5 squared. And what do you know? We have a term squared and minus another thing squared, right? One thing squared minus another. So let's go ahead and let's identify A and B. A here is x. B here is 2y plus 5. Again, we're going to do the difference of squareds. So the formula says take A, and we can add B to it. So I'm going to add 2y plus 5. And then take A, and I'm going to subtract 2y plus 5. But notice what I wrote here for the answer. Notice that the sign changed right there with the 5. Okay? It's because I'm subtracting all of 2y plus 5. Okay? I'm not just subtracting 2. I have to subtract all of 2y plus 5. So I got to subtract 2y, and I got to subtract 5. I had to distribute that sign through it. This is where a lot of students were making their initial mistakes. They were just saying x minus 2y plus 5, right? Well, no, you're not saying just subtract the 2y. You're saying subtract the whole thing. Subtract the 2y and the 5. So that would be the correct answer here. You would have to distribute the negative through. Please make sure you're being careful with how you have to distribute the negative. Be comfortable with the idea of when you're subtracting an entire expression, right? Not just a number, an entire expression, you have to go and actually distribute the sign through it. Okay? This was the idea of factoring by grouping, different than our typical approach. This one, we said, you know what? Free reign. Put the parentheses wherever you want. Okay? And we learned a new way of making a more educated decision or a little more clever decision about where to put those parentheses. Now, this one, a lot of people seem to be comfortable with this. This one really required the idea of substitution. So this polynomial right now, it's very elaborate. A lot of people might think, oh, we're going to have to square this whole thing, distribute the 6. We're going to have to distribute the -7 through to everything, combine like terms, and whatever we get factored down. You could. That's not impossible to do. That's very, that's a very plausible process to implement. But it might take a while. Notice that this polynomial looks a lot like 6x squared minus 7x minus 5. Doesn't it kind of look like that? 6x squared minus 7x minus 5. And maybe I shouldn't have used x. You know what? Let me change this around. Let me use a variable like u. Some other kind of variable, just because sometimes people get confused if I use the same variable twice. Don't these polynomials kind of look alike? Right? I have a number times something squared. I have a number times something, and then the constant term by itself. Doesn't that look a lot like just a standard trinomial? Well, the idea here is go ahead and let's actually perform a substitution. We're going to say, let u equal x plus 2. I'm just picking some variable. Typically, this is called a u substitution because we tend to pick the variable u. Pick whatever. Don't pick the same variable. Don't pick x, but pick something like y or z or k or whatever, okay? So here I'm going to say u equals x plus 2. So really, this looks a lot like this. And we can say that the same thing because I defined what u was, right? I can just go ahead and re-plug these back in, can't I? But bear with me. The reason that we are changing this into this is because the simplified trinomial can be factored. Let's try to factor it down. Let's do AC method. 6 times negative 5 is negative 30. What are the factors of negative 30? Negative 1 and 30, negative 2 and 15, negative 3 and 10, and then negative 5 and 6. And of course, you could also have 1 and negative 30, 2 and negative 15, 3 and negative 10, 5 and negative 6. All right, which of these adds to negative 7? Which of these adds to that middle term? Well, that should be 3 and negative 10. Those will give us a negative 7. So I'm going to rewrite this polynomial as 6u squared plus 3u. Then we're going to add on, let's see, I have a negative 10u and a minus 5. So let's factor out the GCF here. 3u, and we're left with 2u plus 1, minus 5, and we're left with a 2u, and negative 5 divided by negative 5 is positive 1. And what do you know? There's that common binomial, so I can factor out the 2u plus 1, and what are we left with? 3u minus 5. We have just gone, and we factored down this polynomial. Oh, but wait a minute. Our answer had x's in it. This answer has u's in it. Well, what do we do? How do I get back to where we started with x's? Well, don't panic. Just think, well, you know what u is. You said u is x plus 2. So let's go ahead and take 2 times x plus 2 plus 1. That's the first factor. And then the second factor is 3 times u, which is x plus 2. And then I'm going to subtract 5 from it. What you're doing here is you're saying, with this whole polynomial, let's factor the form of the polynomial. Let's break down what the form would look like, okay? So we kind of ignored what the x plus 2 is doing here. Right? That's why we put in what's called a dummy variable, just something to represent it for the time being. Because really what I want to break down is the general form of that original polynomial. And when we do break it down, we can then re-sub in what we get. So if you wanted to simplify, it would be a 2x plus 4 plus 1, which 4 plus 1 is just 5. So 2x plus 5, and then here we have a 3x plus 6 minus 5. Well, 6 minus 5 is just a positive 1. And there you go. The original polynomial can be factored down into 2x plus 5 times 3x plus 1. The idea here is, again, we're just breaking down the general form of the polynomial, okay? And once you break it down, the general form that is, then you can sub in what the variable represented. The last problem I wanted to review from last week was from section 6.5 to 6.6. This is when we were factoring down binomials, special case binomials. So this is where we had the sum and difference of squares and the sum and difference of cubes. And you had formulas for each, and you'd realize, well, the sum of squareds was prime, and the difference of squareds had a particular formula that was kind of easy to come up with. But the sum and difference of cubes had a bit more elaborate formula. One of the big things that you first have to do that I find students tend to skip over, and this is where they get tripped up a lot, you first have to decide, what formula are you using? Is your binomial a cube or a squared problem? And then is it a sum or a difference? And this is where people, because I think people tend to get in a rhythm when they start solving these problems, and they tend to work pretty quickly. Instead, I'd say slow down your work and take some time to, before you begin, really think what the setup of this problem is going to be. So here, obviously, this is going to be a sum problem. So it's going to be either a sum of squares or a sum of cubes. Which do you think it would be? Well, I'm looking at the exponent here. I'm seeing a cube. So I'm thinking, okay, that's probably a sum of cubes. So what I should be able to do is write this 16x cubed as some value cubed. Well, it's going to have an x in it, because when I take x cubed, I get x cubed. But what cubed gets me 16? And what cubed gets me 54? Here's where a lot of people made their initial mistake. They didn't check. There's a GCF in here. 16 and 54 are not cubed numbers. No way. No. There's nothing that, multiplies by itself 3 times to get 16. So what I'm going to suggest we do here is let's go ahead and let's actually simplify this by first pulling out the GCF, okay? Because first off, looking at this is not a sum of cubes problem, because 16 and 54 are not cubed numbers. I don't care that x is a cubed number. The rest of it isn't. So let's see. Let's try to pull out a GCF, and we're going to have our fingers crossed that, when we factor out the GCF, that the numbers become cube numbers, perfect cubes. So the GCF here, let's see, 16. That doesn't go into 54, but 8, no. 4, no. Let's factor out a 2, and let's see what we're left with. So if I factor out a 2, I'm left with an 8x cubed plus, 54 divided by 2 is 27. Okay. Are 8 and 27 cubed numbers? Meaning, do they have perfect cube? Are they perfect cubes? Do they have whole number cube roots? And the answer is yes. So what I'm going to do is I'm going to put the GCF just on the outside here. I'm going to kind of section things off. How can I write 8x cubed as a value cubed? What cubed gets me 8x cubed? Well, that should be a 2x. Because 2x times 2x times 2x. 2 times 2 is 4, times 2 is 8. And x times x times x is x cubed. So there we go. I just took the cube root of 8x cubed. Now what's the cube root of 27? What cubed gets me 27? Well, that's going to be 3. 3 times 3 is 9, times 3 is 27. So I now have figured out what values are being added together and cubed. So let's remind ourselves of the formula. I'm going to write it up here in red. You got to have these formulas memorized just because they're pretty elaborate and they'll pop up quite a bit more. So if you have a cubed plus b cubed, you're going to write your answer as follows. It's going to be a plus b times a squared minus ab plus b squared. What you have here, this is the form for the factored down version of the sum of cubes. First off, you should know what a and b are. You should know what values are being cubed, because then you're going to add them together, then you're going to square the first one, you're going to subtract the product of the two, and then you're going to add the last one squared. Okay? Remember that the signs follow the SOAP method. Same, opposite, always positive. So since you started with addition, this problem's going to start with addition. Then it's going to swap to the opposite, which is subtraction. Then it's going to end with always positive. Just a little, mnemonic device to help you out. Or is it an acronym? Yeah, I think it's actually an acronym and not a mnemonic. I never remember the difference. All right, let's go ahead and right here, let's remind ourselves what a and b are. A here is 2x and b is 3. Now, don't forget we do have the 2 on the outside. this is what we're factoring down. Okay, so I just keep writing the 2 on the outside and then sectioning off the rest of what we have. So I'm going to start with, gosh, that's a terrible bracket. My stylus wants to kick out on me here. Okay, let's start off with the first thing. I need to take a plus b. So that's 2x plus 3. The next thing I have to do is take a squared. So I have to take 2x and square that whole thing. I did not write 2x squared. These are not the same thing, okay? Because I need to square all of 2x, not just the x here, okay? So if I square all of 2x, I should end up with a 4x squared. Then I have to subtract. Now let's multiply a and b. 2x times 3, that should just be a 6x. And then I'm going to add b squared. Well, b is 3, and 3 squared is 9. That is our final answer. This is the final factorization of the entire thing. What I did was I started by factoring out the GCF, and then what was left, I noticed that it was in the form of the binomial that I wanted, so I broke that down into the 2 factors. So the final 3 factors are the GCF of 2, and then the factors of 2x plus 3, and 4x squared minus 6x plus 9. Some people would say, well, can your factor actually be a trinomial? Yeah, that's totally fine. Nothing wrong with that. And then they might say, well, can't you go and factor this down some more? Go ahead and give it a try. See if it works. You're going to do the AC method, 4 times 9, which is 36. So what multiplies to get you positive 36, but adds to get you negative 6? See if you can do it. You won't be able to. This is actually going to be the fully simplified version. But you can give it a try, see why it doesn't work. But this is the answer to problem 3 from the exit ticket as well, something that students were struggling with. A lot of times people would forget, to write the GCF at the end there. So you'll notice I always write it. For me, I have to always have it there, because if I don't, I'm probably going to forget too. All right, I'd like to get into section 8.2, which is today's topic, 8.2 and 8.4. I don't want to get into 8.4 just yet because I feel like that might be a bit much for this live stream, but I'd like to start with 8.2. I'd like to go through a couple of the independent practice problems that traditionally students tend to struggle with. So here are 2 of the functions that I've given you. On the worksheet, I give you a number of functions. Here are 2, and there are 2 examples here, or there are 3 examples here. What I'm asking you to do is to just evaluate these functions. In problem number 2, I'm saying, what is g of 2? That means go to the function g and plug 2 in for x. All right, easy enough. That's 2 squared minus 3 times 2 plus 7. All I've done is every time I see an x, I plug 2 in it. That's what this means. We give functions names because, well, you'll see on the homework, I give you 4 or 5 functions, right? What would happen if I named them all the same thing? What would happen if I called them all f? How would you know which function to work with, right? If I'm going to have multiple functions, I got to give them different names. So I give them like f, g, h, k, maybe m, n, whatever, you know. You gotta name them so you know which one the reader knows which one they have to work with. Additionally, I got to tell you what to plug into it, right? What I'm saying here when I say g of 2 is take that function g, all right, this one, and plug 2 in for x. So we did. And what do we get? 2 squared is a 4, minus 6 plus 7. Let's see, 4 minus 6 is a negative 2. Negative 2 plus 7 is a positive 5. And there you go. When you go to the function g and you plug 2 into it, you get 5 out. Now let's take a look at problem 5 from the independent practice. Same function, g, but this time plug in negative 2. Notice what happens here. Negative 2, I'm going to wrap that in parentheses, and I'm going to say square it. Minus 3 times negative 2 plus 7. What we're saying here is square all of -2. Okay? Don't write this. That's not the same thing as this. They are not the same thing. The reason is this tells us to square all of -2. This tells us to only square the 2 and make it negative. So this would be a -4, +4. Okay? The exponent only affects what it's immediately touching. Okay? In this left example here, the exponent has nothing to do with the sign. It only affects the 2. Versus the example on the right here, the exponent is touching all of -2, so it's going to square all of that. Okay, so be careful with that. When you plug something in for x, I traditionally always write it in parentheses. Even if it's positive, I would have gone through in the first problem and put parentheses around that 2 there. So -2 squared is +4. -3 times -2 is +6 plus 7. And 4 plus 6 is 10. 10 plus 7 is 17. There we go. There's our final answer. Okay. Now let's step it up a little bit with problem 4 from the independent practice. This is saying go to the function h and plug in -5. Oh, well, this one's different. I got to go to this function now, the h one. And every time I see an x, I have to change it to -5. So let's take negative, and then we have x squared. Well, that's -5. I'm plugging that in for x, and I'm using my parentheses here. Okay, so I plug in what -5 is, and I have to square that, and then subtract 3. You'll notice I have some double negatives going on here, as well as squaring. Let's see what happens. Well, remember your order of operations. You got to do exponents first before you multiply these negatives together. Let's do the order of operations, and let's square the -5. Since I'm squaring all of -5, because that's what x was. X was -5 here. That's what I was told to plug in. I got to square all of that. It will become a +25. So when I square -5, I get +25. But don't forget, there's a negative still on the outside and a -3. So that negative on the outside keeps my 25 negative, okay? Sometimes people look at this and they say, oh, that's -x squared, which is just the same thing as x squared. No, they are not the same thing. Do not think that. Get that out of your head. The reason is, and I know it's tricky. I know it's very obnoxious. It's very obnoxious of our notation to do that, right? What this is saying is square only the x, okay? Only square what was put in for x and then make it negative. That's what this part is saying here. So we squared what was put in for x, which was -5, and we got 25. But then I have to make it negative. So that's why I end up with a -25 minus 3. And -25 minus 3 is -28. And that would be our final answer here. Now, please be careful as you work through section 8.2. A lot of times people get overly confident with some of these problems. And I get it. You know, they're pretty easy. They're pretty straightforward. You've been doing this since Algebra 1, since probably even in 8th grade or whatever. But the thing that I really am trying to test you on here is how comfortable are you working with these exponents and these more elaborate expressions when you have to plug negatives in and square things, or when you have to square something and then make it negative like we have in problem H here. So be careful as you go through these, especially the advanced practice. I made sure that the advanced practice had quite a bit more of these squaring practices in it. So take your time. And I would suggest always using parentheses. As you can see, especially with problem 5 here, my use of parentheses was very helpful for me because I could see what needed to be squared and what, all of what I was squaring, not just the number, but the sign as well. So be careful with that. Make sure you're checking your work and let me know if you have any questions. Right now, I don't see any questions in the live chat, and I haven't received any yet, so I'm going to end this live stream a bit early. We're going to stop for now. I'll do another live stream today starting at 12:30, And in that 12:30 live stream, I might do a couple of these 8.2 advanced practice problems just to make sure we're comfortable with some of those. And then I'd like to get into section 8.4, which is composition of functions. I'd like to get into that second section that you got to review today. Okay? Until next time, take care.